Hello. Hello, welcome everybody to this info session. Today we will present you this Teaching Factory competition, which is a flagship initiative for education in 2022. So you will very shortly know more about the call that is open, addressing companies on one side and RTOs, and on the other side universities and VET. So I want to draw your attention on the unicity of this method. I will maybe illustrate a little bit later how this method is unique and how it differentiates with towards other forms of collaboration with and innovation between academia and companies, like hackathons, like thesis, like startup competitions. Teaching Factory is really unique and address in a certain way specific needs and provides results that you will see during the presentation. So please pay attention to what will follow and give the needed and necessary care to listen to this info session. Thank you very much.
Thank you very much, Paula, for the introduction. Welcome everybody to this Teaching Factories competition info session that we organized today from the EIT Manufacturing. My name is Javier Gonzalez. I'm CLC West Education Developer, and I will also present you the main contents of this session that we will have today to illustrate you about what the Teaching Factories competition are, to explain you a little bit about the concept of the teaching factories, so that you can understand it better, how beneficial it could be also for industries and universities and vocational training centers, which are the aims of this call that we have launched. Then we will go a little bit into the detail of the Teaching Factories competition call and some practicalities and how you can apply and how it can be and it can be used by you in order to solve the challenges and also the activities that we are organizing. And then if we still have time, there will be room for a small slot for questions and answers, in which you can put your questions in the chat. You can use the chat in Teams, and then you will be able to see your questions, answer those more relevant, and also if we don't have time, we will try to answer those questions afterwards in the Q&A sections in the website. So thank you very much, everyone, for joining. Before starting, so we will and before going into the detail about what the Teaching Factories competition are, which will be explained by two key speakers that we have today, Harry Vickers from LMS University of Patras and Lars Forner from Volvo Group, to whom we are very thankful that they participate today. Before going into that and that part, so just a couple of words about why this initiative. So, Teaching Factories is a lighthouse initiative of EIT Manufacturing, and in this year, as Paula has mentioned just a couple of minutes before, and we want to promote the use of the Teaching Factories as an educational methodology. We have been working during the last years in this methodology. Projects have already had very good results, and we see that this Teaching Factories methodology can have a very good added value for the organizations to solve their challenges in the manufacturing area. And we will also want to give the visibility to this initiative, to the benefits that they have, in order to foster the collaboration between the academia and business, right? So and also as we are very concerned about the education activities, we are the education pillar. So doing this in this context of challenge-based learning is very useful and very interesting to learn for the young people. So this is an initiative that wants to reinforce this message and wants to make it more visible, the teaching factories. And so pay attention to our visual logo that you have there, because you will be seeing that in the next coming months when we refer to this initiative, right? So, and just as mentioned, in order for you to understand a little bit more what are teaching factories and what is the benefit that is behind, we have a very, very good example today coming from a TF-NONET project, one of the projects that has been funded by EIT Manufacturing, and the examples from LMS, from Harry Vikas from LMS, and Lars Corner from the Volvo Group, which participated in this initiative. And I will give the floor now to Harry and to Lars for doing a small presentation about the benefits of this initiative, teaching this methodology of teaching factories, and then we will have a small open discussion with Volvo with Lars in order to see the benefits for the companies that this initiative can have. So then, Harry, please, the floor is yours for the presentation. Thank you very much.
Thanks a lot. Thanks a lot, Javier. Good morning also from my side. My name is Harry Vikas. I'm a mechanical engineer, work as a research engineer at LMS, Laboratory for Manufacturing Systems and Automation. We are actually the pioneers of the teaching factory concept, and we're also the coordinators of the TF-NONET project. And I'm just going to show a bit what we did in TF-NONET, explain a bit the concept of teaching factories and the way that we applied that, and showcase the particular application example that we had together with Volvo, one of the many pilots that we ran within the TF-NONET activity. So let's maybe start with defining what a teaching factory is, and let's do that by starting actually a bit further away. So starting by the definition of a learning factory. Learning factories are already quite established in the European landscape and the European education landscape. And the learning factory basically is a concept where in the facilities of a university, equipment that resembles actual manufacturing facilities is installed, and people from both academia, but also from industries, from companies, can participate in specific courses that have as a purpose to train them on a specific subject. On the other hand, the teaching factory takes this concept a bit further away. The teaching factory is defined as a two-way street between academia and industry, where from the factory practitioners teach students, and from the classroom students and faculty teach practitioners. Effectively, this is a door between universities and companies to exchange information and learn and co-create together. And this two-way street is usually realized via the internet, and it's a continuous process over a lengthier period of time with regular sessions and continuous interaction between the two actors. The teaching factory basically links manufacturing and education, and links actual production with state-of-the-art developments on the academic side, linking established engineer and established personnel with young engineers that want to observe a problem and start solving that using their state-of-the-art knowledge that they obtain within the academia. The main aim is to develop what we have as a core competence for engineers, and this is the problem-solving capacity. So the way that this operates is that there are challenges that are faced by industrial manufacturing companies in their daily business that can be solved by a student or by a group of students through this remote collaboration scheme. Let's dive into a bit more detail. So as we say, a teaching factory is basically an open window, an open door between industry and academia. It constitutes a two-way communication channel between the two, and we have knowledge flowing both ways. This knowledge exchange can use both physical and virtual operation schemes. It can be used to link parties that are physically distanced and apart. In this particular case, we will see an example later on of such a collaboration between Volvo and different universities and entities located in Europe, but in totally different countries. The concept is that on the one hand, there's information flow from factory to the classroom, passing on industrial practices and practical knowledge, but giving also the opportunity to students to observe problem-solving techniques and methods, learn to work in teams, and most often than not in international teams, and better align their academic research with what the industry really needs. On the other hand, we have information flow from the classroom to the factory. So we have new concepts, state-of-the-art technologies information about state-of-the-art technologies actually being transmitted to the factory. We have an environment that can foster research and consulting and development of new solutions and proof of concepts in academic premises, which can then be undertaken by the industry. We have remote access to facilities with high-grade industrial didactic equipment, and we have, let's say, a form of outsourcing of new ideas to such problems, which eventually leads to better decision support due to multiple potential solutions that exist on that challenge. How does this collaboration work then? As we mentioned, Teaching Factory is facilitated by advanced ICT and high-grade industrial didactic equipment and operates as a bidirectional knowledge communication channel, bringing the real factory to the classroom and the academic lab to the factory. This collaboration happens through a platform and through advanced ICT tools, and it can happen in different ways. So we can have both synchronous and asynchronous communication, and we can have context and content modular configuration, allowing learning and training on multiple study contents, engaging different factory facilities, engineering activities, delivering mechanisms, and academic practices. We can see a characteristic example of that in this particular slide, where students have the opportunity, for example, to watch augmented pre-recorded videos from a warehouse, as an example, on how raw materials are handled, and this can be in the form of an asynchronous session, or we could have synchronous sessions where engineers present a certain operation and students are able to interact with the engineers from the classroom and from multiple locations. So we can have students being present in a specific classrooms. We can have multiple classrooms connected at the same time in different locations, or we could even have students working from home, as was the instance in the last couple of years due to COVID, and still be able to have this live interaction with the companies. The main benefit of these live sessions is that they act as a live interaction or as a substitute of a live interaction between the student teams and the engineering teams, and they act as tutoring sessions. So when student teams develop a solution and have questions that need to be decided or require guidance about specific subjects, tutors both from academia and industry can help them and steer them in the right direction, providing advice, but also useful criticism in the potential solutions that are being developed. This can be extended also in different areas of the factory, in different types of study and different study content, using different delivery mechanisms, ICT technologies, and different classrooms, but different organization also of the online sessions. So we have a very modular tool in our hands that we can configure in any way we like, depending on the specific problem that we're trying to solve, the specific student groups that are participating, and the specific industries that are posing the challenges to the network. Taking this whole Teaching Factory concept one step further, what TF-NoNet project has been trying to do over the last few years is establishing a network linking industry and academia and developing a method and the tools to work together in solving such industrial challenges. The end goal is to mutually develop skills and promote and share expert knowledge. And we have multiple possible modalities that can be used in order to do that. So we can work towards solving industrial innovation challenges. We could work towards training and upskilling, and we could work towards collaborative remote teaching. And we have tested all of these modalities through a number of pilot activities that have been running over the last 2 years. Overall, the network links industrial and academic actors as different nodes and facilitates the launch of collaborative manufacturing training projects with mutual interest. Participating organizations can effectively exchange information, including training material, virtual access to state-of-the-art infrastructure, real industrial challenges, and novel solutions. And the Teaching Factory Network also functions as a virtual forum of actors around the knowledge triangle, so integrating education, research, and innovation in manufacturing. In general, we could say that we have two types of organizations, classified in two different boards, if you may. The academic board, comprising mainly universities and research centers, focusing on providing novel concepts, approaches, and remotely accessed test beds to address both industrial needs and innovative educational schemes. While on the other hand, the industrial board has the chance to express their needs in terms of challenges that need to be elaborated together with the academic actors in order to develop novel solutions. In order to make that more clear and understand it a bit more in practical terms, how it operates, let's look at the example of one of the pilot activities that was run with Volvo Trucks within TF-NONET. The aim here was for the students to collaboratively work on solving an industrial challenge that was presented by Volvo Trucks, with participation of trainees and tutors from 3 different universities, in this particular case, LMS and University of Patras, Aalto University, and Politecnico di Milano. The challenge in this particular case was focused on introducing digital and dynamic assembly work instructions in the manual assembly environment of heavy-duty trucks. In this particular case, we had the problem that the customization level of a truck corresponds to very specific requirements of its customer. So we had a challenge that was divided in basically 2 assignments. The first one was to identify different parameters that could affect both positively and negatively the product quality as it regards assembly instructions. And the second one was to address the most important of those parameters by proposing a logic on how such a parameter could be used in a decision support functionality. The pilot itself spanned the duration of 10 weeks with 2-hour sessions every week between Volvo and the students on a fixed time slot. And this was done as a tutoring session to monitor the progress of the teams, but also guide them in developing the solution. We had 3 different teams with 8 students participating in the pilot, with each team developing a different approach and presenting a different potential solution to the challenge. Again, this is only one of the examples that we have had during TF-NONET, and the benefits arising from that was that, of course, students got to know how a company like Volvo works, get to know how to apply their theoretical skills in practical terms, solving a practical industrial challenge. They challenge their creativity and they work together in international teams, learning how to deliver on time, how to present, and how to work with tight deadlines. On the other hand, Volvo had the chance to collaborate with young students that provided different solutions, so provide a better decision support, let's say, on that front, and had the chance to look how state-of-the-art solutions could be implemented in potentially in a production environment in order to solve the particular problem. This summarizes more or less what was done in TF-NONET, and I hope that it gives a bit better insight, let's say, on how such an example could look like in practical terms.
That's great, Harry. Thank you very much. Thanks a lot for your great presentation. It was really very, very interesting to understand very well the concept of the teaching factories. And now I would like to invite Lars Forner, coming from Volvo. Good morning, Lars. Thank you very much for joining. As you have already participated in this project and this initiative, and I would like to ask you, what has been your experience within this TF-NONET project with the teaching factories, and what can you highlight as a good experience for an industry like Volvo?
Yeah, thank you very much, Xavier. It's been very positive. Basically, I would say, I mean, yeah, maybe to make a short introduction. I'm working as a project manager within Group Technology, and basically the manufacturing part is not my expertise. But we have identified, let's say, for the engineering side, the product development side, more that we need more knowledge about how to manufacture, design for manufacturing. So that was actually a starting point when I came into this this initiative where we set up with Harry and his team, and that has been very much positive because my experience in that area setting up this type of training was very limited, I would say. We have a lot of we have this Volvo Group University that I also collaborate a lot with. So for the need that we identified, this was of course very much helpful to increase the awareness of the tools that we work in and also the manufacturing processes and so forth. And that's it's been a real pleasure to work with Harry and his team, and that's been a great success for us, I would say.
No, that's great. So thanks a lot. And what do we think could be the main benefits that these initiatives or the teaching factories can provide to you as Volvo from this example, and also to be extended to the rest of the industries that also want to try the teaching factories methodology?
I think the setup and the support we can get to set up this type of training with the expertise. Volvo is a big company, and of course networking is within the company is a key thing. And my network with this this expertise, I would say, is quite limited. So having the support from the team with the setup and the guidance on how to perform this. Adopted, of course, together with the way we set up the training here with the smaller, let's say, lunch and learn sessions to increase the awareness and then increase the, I would say, curiosity of from an engineering perspective to understand more and how to utilize the tools that we're working in a more efficient way. Yeah. There are so much things happening in that area with the AI and generative designs and all that advanced functionality we have available in tools, but we're not utilizing them. Yeah, no, super nice. So Harry, please, if you want to jump in, don't hesitate to jump in to make any comments. Now I would like to ask you both, as you are coming from different organizations, or Lars is coming from the industry side, and Harry is coming from the academia side, university side. I would like to ask you, so you put you in the position of a potential applicant to these initiatives, and then just what would you recommend them, or what would you advise them in order to apply for these initiatives? As you already know, this year the main thematic in which we frame all the activities is green manufacturing. So according to your experience, we can start with you, Harry. From the university side, so what would you recommend to a potential applicant which wants to participate here? So where to focus or where they should take care in their application?
Well, we have seen a couple of let's say challenging points for universities that are new to this scheme that are related to self-organizing and to move forward with their student groups. What I would say is needed on that at the beginning, at least, is setting clearly the teams and having clear expectations about the outcome. Sometimes also what we have seen is people that are too skeptical about diving in such a concept. I think that the concept itself has so many benefits, both for universities, but also for industries, that people should not be really thinking of this twice. And the nice thing here, the nice thing about this initiative is that it provides the opportunity to everybody to basically test that firsthand. So I would say that I see a huge benefit here. It's an activity with no actual risk for applicants. The application process is very straightforward. We are already going through that ourselves because we want to be part of that. So what I would suggest and what I would say to everybody is just dive in, do it, see if you like it. I promise that you'll like it, according to our experience so far. So yeah, just go in, apply, and investigate. Let's say find out for yourselves.
Yeah, that's great. Absolutely agree with you. Thank you. And from on the industry side, Lars, so what would you advise to those industries that are that are now in touch with this initiative, with this methodology, and okay, so why not try? So what would you advise for the industry side?
Well, from my personal experience, I started up, I saw a need for training and a need to, let's say, broaden the interest of working more towards production and closing the gap between engineering and manufacturing, I would say. So I just started up with one PowerPoint slide, where I had the opportunity to present to Harry and his team. And no, that was my basic ideas that I had, and with this small effort, that from my side, I would say we had a couple of meetings, and in a month or so we had more than 100 participants on the training. So the best advice I can give, as you mentioned there, Harry, don't wait, just do it. I mean, that is my definite experience that I had with Harry and his team here.
Exactly. So that's very good. And in fact, we have some good news. I will present that afterwards, so that we on that front to encourage people to participate and to have more time for applying. So I will go now to this point. And yeah, but I would like to thank you very much for your contributions, for your experience here, for sharing this time with us, and also giving us the overview of the value of the teaching factories and how beneficial it can be for the industry and for the academia and the universities. Thank you very much, Lars and Lars and Harry, and hope to see you soon in future events, future initiatives, and why not applying to the teaching factories competition. Okay.
Thank you.
Thank you very much
for having us.
Yeah,
Thank you for having us.
yeah, welcome. Very welcome. Thanks a lot for your time. Now we will be moving to the specific